Okay, we'll see how Pythagoras and trigonometry are related to each other. In a right angle triangle, A, B, C, right angled at B, Pythagoras tells us AC square is equals to AB square plus BC square. This is hypotenuse, perpendicular or base or perpendicular, whatever, depends upon the angle which we decide. Let us say this angle is represented by theta, right? So if I want to relate Pythagoras with trigonometry, trigonometry is a side ratio concept of right angled triangle, and Pythagoras is the concept of the square of the longest side is equal to sum of the square of other two sides, or the sides including 90 degrees. So how can we relate the ratios with the Pythagoras result? It is quite easy to do by dividing both sides by square of any side. Let's start with AC square. Dividing both sides by AC square. So why I'm doing so? So that we can express the result as ratios. So what is AC square by AC square? It's 1. AB by AC can be written like this from the concept of exponents. BC by AC also is taken like this. Now what is AB by AC? According to this angle, AB by AC is sine. See, what is AB? According to theta, this is perpendicular, and AC is the hypotenuse. Perpendicular upon hypotenuse is ratio, which is called the sine of the angle. Next, BC by AC. What is BC according to this theta? It's base. Base upon hypotenuse. So what is base upon hypotenuse? That is cos of theta. Now I would like to tell you sine theta is a ratio, and this square means square of the ratio. Cos of that angle gives a ratio, then square of this ratio. For the same angle, this result says whatever the ratio you get for sine theta, square it and get the ratio of cos theta, square it and add them, you'll get 1. So this result is taken as identity. Write it as this or this, doesn't make it any difference, because sine itself is not explainable in trigonometry. So sine of the angle, so you have to take the square of the ratio. So this result is also termed as identity, trigonometric identity, a result which you have to again remember, driven from the Pythagoras. So what this result gives us? It gives us sine square theta plus cos square theta equals to 1, which I have explained this, that square of the same angle of sine and cos, when added up, they will give you 1. So you have two results further to remember. One is sine square theta can be expressed as 1 minus cos square theta, as it will be required in a question. Similarly, cos square theta can be written as 1 minus sine square theta. So if you remember the first identity properly and you know how to transform from there, you have learned 3 identities. So this is the first identity which you have to remember. This was the first case. The second case AB square, or the other side also you can do, whichever you feel like. AB square by AB square, BC square by AB square. So AC by AB square is 1 ratio. This is 1, and BC by AB square. So what is AC by AB? This is hypotenuse and this is perpendicular in reference to this angle. So what are you getting from this? AC by AB, it's hypotenuse upon perpendicular. It is
cosecant.
cosec theta. BC by AB, base upon perpendicular, that is cot theta square. Another result, but I'll transform it so that you should remember this result as the difference of the square of cosec square minus, that is, cot square, equals to 1. So difference of the square. Initially the result was sum of the square of sine square and cos square of the same angle gives 1. Here the difference is going to give you 1. So from here you can transform two results. One this one, or the second one is that cot square theta is cosec square theta minus 1. So we can take this as A and this as B. So although we have got this result, but remember identity with 1. So this is the second result from the same figure. Similarly, you will have the third one also. So what is that? Let us see.
Excuse me, sir. Excuse me, sir.
Now we will divide this by BC square. AC by BC square, AB by BC square. Finally, this is 1. So for the reference, I'll make the figure here again. Hypotenuse upon base, secant square theta, and this is tan square theta plus 1. Secant square theta minus tan square theta equal to 1. So this is the identity number 3, which you have to remember, and transforming that you will get another 2. One is this, another is in terms of tan square theta. Generally, this identity students make mistake for transformation. They make 1 minus secant square theta. No, it is secant square theta minus 1. So I'll conclude by writing the main 3 identities which you should keep in your mind in a sequence, and you have to remember that this identity is for square of the sine. It is not sine theta plus cos theta is 1. No. Square of the ratio of this plus square the ratio of this gives you 1. Then we have difference. Then 1. Cosec square theta minus cot square theta 1. So if you remember these 3,